Our lesson for today, we are going to look at how to write compounds. This is lesson 101. We are busy with chemistry 1501. Let us start. We know that we have different types of elements with different properties, and we find those properties and the symbols of the elements on top of the periodic table. We normally say the first 20 elements are important, but in this lesson video we'll be dealing with a vast number of elements. So just know that a periodic table contains or consists of symbols of elements, their atomic number, their electronegativity, their atomic mass. So today we are going to deal with how to write the compounds. We know that a compound is a combination of two or more elements to form a molecule. Now the first thing that we need to take note of is the diatomic. We have diatomic elements. Diatomic elements, it's those type of elements that cannot be balanced in an equation if you write it in a form of one atom. Like for example, let's say we want to write the chemical reaction of hydrogen and oxygen to form water. We know that in order to get water, which is H2O, we need to react hydrogen and oxygen. Now the diatomic elements, when they're in this state, they are not stable. So the reason why we say they are diatomic elements, hydrogen, to be stable it needs 2 atoms, and also oxygen to be stable it needs 2 atoms. We have 7 diatomic elements all in all, and then hydrogen and oxygen, they are one of those elements. Looking at other diatomic elements, we have F2, fluorine, it's a diatomic element. We have Cl2, chlorine, which is also a diatomic. We have iodine and bromine, and then lastly we have nitrogen. So these are the diatomic elements you should take note of. Whenever there's a statement says an element reacts with one of these, or these elements they react together, just know that you don't have to write them in terms of one atom. You need to write them in a diatomic manner. Now remember that di in chemistry means 2, so this di comes from this subscript that you see here. Another chemical reaction that contains or consists of diatomic elements is the formation of ammonia, NH3. We can see that we need to react nitrogen and hydrogen, and then both of them, they are diatomic elements. And then once you understand this diatomic element, it will be simple for you to know how to balance the equation. Now what is important is to figure out this product, and then you can see that this product consists of nitrogen and hydrogen. Then from there you simply write the elements, and then remember that since they are diatomic, you must include the subscripts, and then from here you balance the equation. Everything will be simple. And then another reaction that you should take note is combustion. Combustion is when we talk about any element reacting with oxygen. So let's say we are looking at the combustion of magnesium. It will be magnesium, it's not a diatomic, and then oxygen is a diatomic to form MgO. So whenever they say combustion, just know that oxygen is a diatomic element, so include this 2 here. Our next discussion will be how to form compounds, not ionic compounds, how to form compounds. Now we should know that in group number 1 the formal charge is 1 plus. You should know that each and every element in group number 1 they have a formal charge of 1 plus. In group number 2 they have a formal charge of 2 plus. In group number 3 they have a formal charge of 3 plus. In group number 4 we have 4 plus, 5 plus, 3 minus, 2 minus, 1 minus, and then we have 0 here. So these formal charges will assist us on how to write the compounds. To make things easier, just have a copy of this periodic table and then simply write these charges on top, so that when we do the examples you don't have to go back and check this periodic table. Our first example, let's say we are reacting magnesium and bromine to form, but remember that bromine on the reactant side must have 2 atoms since it's a diatomic. Now we want to know what type of a compound it will form. Remember that we might have something like this. There are many ways we can actually think of this type of compound that might be correct between the 3. Now how do we figure out which one is correct? We are going to use the first method, which we call it a crossover method. Now we go ahead and look at the formal charges of these elements. Magnesium is in group number 2, it has a formal charge of 2 plus. And then bromine, it's in group number 7, it has a formal charge of 1 minus. So in this case, when we use the crossover, what we are going to do, we are going to rewrite this, but we don't omit or we don't include the charges. And then what we do, we are going to cross multiply. This 2 will come here, this 1 will come here, and then this will result into Mg1 Br2. So this will be the product of these 2 reactions. Let's look at another example. We have sodium reacting with chlorine. Remember that chlorine is a diatomic element. So we look at the 2. Sodium is in group number 1, it is 1 plus. Chlorine is 1 minus from group number 7. Now we have something like this. When you cross multiply, we are going to have NaCl. So NaCl will be our product. We look at the reaction between hydrogen and fluorine. Then we know that hydrogen is from group number 1, fluorine is from group number 7. So basically we have something like this. Then when we cross multiply, we are going to have HF. So HF will be our product. Our next example, let us look at the reaction between magnesium and chlorine. What will be the end product of the 2? Magnesium is in group number 2, it has 2 plus, so we're going to take 2. Chlorine is in group number 7, it is 1 minus, so we're going to take 1. Then when you cross multiply, we are going to have MgCl2. So MgCl2 will be our products. Our next example, let us look at iron 3 reacting with chlorine. Then let us look at their products. Iron 3, it has 3 plus, and then chlorine has 1 minus. Then we have something like this. 1. When you cross multiply, you are going to have FeCl3. When it reacts with iron 2, it will have FeCl2. Let us look at reaction between magnesium and iodine. Remember, it's a diatomic. So in this case, magnesium will bring its in group number 2, then reacting with iodine in group number 7. Then on cross multiply, we are going to have MgI2. Our next example, let us look at sodium reacting with nitrogen. Then sodium is in group number 1, it has 1. Nitrogen has a formal charge of 3 minus, but let us take 3. Cross multiply, you are going to have something like this. Let's look at the products of elements bonding with those complex ions. Potassium reacting with nitrate. In this case, it's very important to know that nitrate has a formal charge of 1 minus. So in this case, we know that potassium is from group number 1, so it has 1, and then reacting with nitrate, which has also 1. When you cross multiply, we are going to have potassium nitrate. This, we regard this as a complex ion. Let's look at those number of complex ions. We have NO3 minus, we have NO2 minus, we have SO4 2 minus, and SO3 2 minus. These are the most common ionic compounds we have. This we call it nitrate. Then this we call it nitrite. Should it happen that they tell you that then a certain element reacts with nitrate, you should know that this is the ionic compound. The molecular formula of this particular ionic compound. Then this will be sulfate, and then this will be sulfite. Remember that in this lesson video, I'm just teaching you how to generate the compound of the product when we react elements. Our next lesson video, I will teach you how to name these elements. So take note of this. Now let us look at the first example. Let's say hydrogen reacts with nitrite. You know that hydrogen is from group number 1. Since it's from group number 1, it has 1 plus, and then nitrite has 1 minus, meaning that when you cross multiply, we are going to have something like this. Once you understand this, you would be able to write the product of reacting potassium and nitrate or nitrite. You should be able to react a lot of things. Now let's say we are reacting hydrogen and sulfate. can see that the two hydrogen from group number 1 it has 1, sulfate it has 2. So in the cross multiply, we see that we are going to have H2SO4. So in this lesson video, you should be able to know how to react the two, and also when you're given this, you know how to expand this. And by the way, when you're dealing with ions in this case, it is proper to include these ions here. Let's look at chemical reaction between copper 2 and nitrate. Remember, for the sake of practice, you can pause the videos and play after you are done writing your answer to verify the answer. Now in this case, let us look at this. Copper 2, it has 2 plus. So you're going to have C2 reacting with NO3 1. When we cross multiply, you should understand that this, we consider this as 1 unit. So this 1 will come here, then this 2 will come here. Then it will be Cu, we open bracket, and O3, we close the bracket. So now you know how we actually form these compounds where you see these brackets. Let's look at a bit challenging reaction. Let us react ammonium ion and phosphate. You should know that phosphate has PO4 minus, and ammonium ion has NH4 plus. So in this case, we have PO4 and reacting NH4 with 1 here. In the cross multiply, we are going to have, we normally start with ammonium NH4, then this 3 will actually come here. Then we have PO4, this 1 will come here. So it's basically 1. So this will be ammonium phosphate. Another reaction that we can look at is aluminium 3. It's actually aluminium that has 3 plus silicate. Silicate is SiO3 2 minus. Once you know this ionic compound and element, then it will be simple for you to actually predict or know how to figure out the product. So we have 3 and then we have SiO3 2. When we cross multiply, we should introduce a bracket. So we have aluminium silicate, which will be like this. This 2 will come here, this 3 will come here. So we have 2 here, we open bracket, SiO3, then we have 3 here. Let's look at sodium reacting with thiosulfate. Sodium like this, and then thiosulfate is S2O3 2 minus. Then in this case, we are going to cross multiply. You can see that this 2 will be here, then this 1 will actually be, we don't have to introduce a bracket because we know that 1 multiplied by this subscript will give us the subscripts. So we have Na2S2O3. Aluminium reacting with sulfur. We know that aluminium has 3 plus, sulfur has 2 minus, then we are going to get Al2S3 since we have cross multiplied here. Then another example that we should look at is reacting magnesium and oxygen. In this case, oxygen has 2 minus, magnesium has 2 plus. Well, since the subscripts are the same, we cannot write it like this. We can just write it like this because the subscripts are the same. Some would say we write the empirical form of it. Well, in a sense of chemistry, we can accept that. Another example would be barium reacting with oxygen. Barium has a formal charge of 2 plus, then oxygen has a formal charge of 2 minus. In this case, we have barium 2O2. Then on the cross multiply, we are going to have BaO. Don't forget to include this, it's a diatomic. Another important example that we should look at is lead-4 reacting with oxygen. Lead reacting with oxygen. In this case, we have lead-4. So lead-4 has a formal charge of 4 plus, oxygen has a formal charge of 2 minus. So we have lead-4 reacting with O2. In this case, when we cross multiply, we are going to get Pb2O4. So in this case, you can see that the subscripts are actually the multiple of each other. So we can divide by 2 both sides to get PbO2. So whenever the subscripts are a multiple of each other, we can simply reduce to the lowest common multiple. So basically, this is how we write the compounds when we are dealing with a scenario whereby we are given the names and then we should generate an equation. Then from here we can balance the equation. Once we know how to write this substances, it will be simple for us to balance the equation. That's it for this lesson video. This is Popular SJ. Thank you very much.